Okay, let's go through the papers. Through the paper. I have to say, well done for sticking through this. It wasn't an easy paper, but well done to the effort that was put into this paper. Right, so first ones were quite simple actually. A to the power 7 times a to the power 4. When we're multiplying, we simply add the indices. So we do 7 plus 4, which is 11. So a to the power of 11. Then here, when we're dividing, we subtract the indices. So 15 take away 3 is 12. So w to the power of 12. Next, some of you did fall down on this, which is understandable. When we've got the brackets, we multiply the indices. So we've got 5 times 2, which is 10. So we should have had x to the power of 10. And then we've got 3 times 2, which is 6. So we should have y to the power of 6. But then it's this bit, the 8, that some of you got wrong. We have to square it because at the outside of brackets it's telling us to square it. It's to do 8 times 8, which is 64. So our final answer is 64, x to the power of 10, y to the power of 6. Next, to change the subject, we are going to, there's lots of different ways you could do this. Some of the ways I've shown you is look at what's happening to t. It's being cubed, and then 8v is being added to it to give you c. So work backwards. Instead of adding 8v, I'm going to subtract 8v. And then instead of cubing it, I'm going to cube root it. So cube rooting is the opposite of cubing. So I should get t equals c, take away 8v, and then cube root the whole thing. Right, next one. Some of you, I think, were worried about which part it was talking about. You weren't sure, so let's go through it together. So it was asking for angle ABC. So ABC, remember it's the middle angle, so it was asking for here, ABC. Now, in order to use trigonometry to find ABC, I need another side, because as you can see here, I've got 5 centimetres of this right angled triangle, but I've got none of the other sides. So I'm going to look at this right angled triangle separately, and I'm going to find this side here, and I'm going to use Pythagoras first. So using Pythagoras, and I've got to be careful because I'm finding another short side. So I need to subtract. I'm going to do 4 squared, take away 3 squared, which gives me 16, take away 9, which is 7. So I need to square root 7. So square root 7, you can either leave it as square root 7 because obviously you're going to use it later on, or you could just make sure that you either save it in the memory of your calculator to use later. So that's 2.65. I now know that this part here is 2.65. Now I can use trigonometry. So looking at this angle here, this is my opposite, this is my hypotenuse, this is my adjacent. I have no information on the hypotenuse, so I don't need it. So I'm only going to use opposite and adjacent, and so that means I have to use TOA. So I'm going to use tan. And if I cover up the angle, it's telling me that the tan of the angle is opposite divided by adjacent. So if I do that, I've got tan of angle ABC is opposite, which is 2.65, divided by the adjacent, which is 5. Now remember, I've told you in class I wouldn't even bother work out what 2.65 divided by 5 is. I would go straight into the inverse tan. So that angle, angle ABC is simply the inverse tan of whatever 2.65 divided by 5 is. And you do that on your calculator and you should get 27.9 degrees. Okay. Right, next one. This one was hard, okay? So let's work it out together. But you did get some marks for figuring out a couple of things. So first of all, we know that the distance 210 kilometres was to the nearest 10 kilometres. So that means we halve it, and to find the upper bound we add 5 kilometres. To find the lower bound we subtract 5 kilometres. So I know that the upper bound of my distance is 215 kilometres, and we don't need the lower bound, but I'm putting it here anyway. The lower bound of my distance is 210, take away 5, which is 205 kilometres. The next bit was a bit tricky because we've got the time in hours and minutes, and we need to find the upper bound in kilometres per hour. And so what I would do is I would first of all realise that my upper and lower bounds, I've got a half 5. So that means my upper bound must be plus 2.5 minutes and my lower bound must be take away 2.5 minutes. And so that means that the upper bound, of my time must be 3 hours and 27.5 minutes. And the lower bound of my time must be 3 hours and 22.5 minutes. So I've subtracted 2.5 minutes. Now, you need to work out the speed. You should know that speed is distance divided by time. They're asking you for the upper bound. To find the upper bound when you are dividing, you need the upper distance. So we're going to do 215 divided by the lower bound of my time. Now, I'm going to turn my time into hours. So I'm going to turn, I'll just do it over here in the corner, 3 hours and 22.5 minutes into hours. Now I know it's 3 point something, and then to turn the 22.5 minutes into hours, I'm going to do 22.5 divided by 60. That gives me 0.375 as hours, okay? Because remember, this is not out of 100, it's out of 60. So I'll just repeat, I did 22.5 divided by 60 to get it into hours. So now I know that I now need to do 215 divided by 3.375. And that gives me 63.7 kilometers per hour. Okay, question 4, we need to factorize. Again, lots of different ways we could have done this, but I would look for the biggest number that goes into 14 and 21, which is 7. So 7 is going outside the brackets. How many 7s go into 14? 2. How many 7s go into 21? 3. Then I can see what's the biggest power of x I can take out is x squared. So I'm going to take out an x squared, and that becomes, instead of to the power of 5, I take away 2, that becomes to the power of 3. I can take out, look for the smallest power so that you can take it out of both. Smallest power of y I can take out is y squared, so I can take out a y squared. And so 3 take away 2 is 1, so that just becomes y to the power of 1. So that all comes outside the brackets. Inside the brackets, I have what's left over. I've got 2 and then y, 2y. So I've got 2y, take away 3x to the power of 3. So 3x to the power of 3. And then close the bracket. And that's it. Right, next one. If you want to divide these fractions, then we have to turn those into improper fractions first. So 2 times 3 is 6, plus 1 is 7, so 7/3, divided by 5 times 1 is 5, plus 1 is 6, so 6/5. It's up to you which way you do it. Some of you cross multiply like this, or some of you do 7/3, change the division sign to a multiplication sign, and then flip the second fraction so it's 5/6. 7 times 5 is 35, over 3 times 6, which is 18. Okay, and then you can turn it back into, you can't simplify it any more than that, so we're going to turn it back into a mixed number. So how many 18s go into 35? 1. Remainder 17 out of 18, so 1 and 17/18. Okay, question 6. Okay, so Paul says that in the last year, Sue's wages have risen by more than Abdul's wage. A lot of you correctly said, we don't know how much they both started with. So if Abdul earned more than Sue, it is possible his wage increased by more. Okay, so we don't know what they both started with. Abdul could have earned more than Sue, and so then his wage increase would be more. Okay, next bit. This was a reverse percentage question because it says work out the value of the national minimum wage before this increase. So first of all, we know the increase was 4.4%. So we do 100% plus the 4.4, which gives us in total 104%. Then we turn 104% into a decimal by dividing by 100. So we move to decimal point 1, 2 places to give me that is the same as 1.044. Remember, because it's reverse percentages, we are going to divide. So we're going to do £7.83 divided by 1.044, which gives us £7.50. And that's it. So £7.50. Write 56 as a product of its prime factors. We've done this many, many times before. Get out your prime factor tree. So 56. So 7 times 8, and we circle any of the prime numbers. Remember, your prime numbers are 2, 3, 5, 7, 11, 13, 17, and so on. So I've circled 7, I carry on with the 8, 2 times 4, circle 2, and then 2 times 2. And so, but in order to get full marks, you need to write 2 times 2 times 2 times 7, or even better if you wrote 2 to the power of 3 times 7. But you must write it as a product, i.e. you've got to write the multiplication sign in. Otherwise, it's not the full answer. Okay, this was a secret LCM question. So any process of finding the LCM, I prefer Venn diagrams. So I've already done the prime factor tree for 56 in part A. So I'm going to do it now for 24. So 3 times 8. 2 times 4, and then 2 times 2. I draw my Venn diagrams for 24 and 56. There's a 2 that appears in both, another 2 that appears in both, and another 2 that appears in both. There's a 7 that appears only in 56. And a 3 that appears only in 24. Remember, to find the LCM, you multiply all the numbers. So I'm going to do 3 times 7 times 2 times 2 times 2. I'm multiplying all the numbers. And that gives me 168. Okay? The other way you could have done it is you could have done the 56 times table, so 56, 112, 224, and so on. And then you could have done the 24 times table. So that's not 224, I don't know why I did that. We all make mistakes. It's 56, 111, 112, then 168, so on. And then 24, I could do the 24 times table, 24, 48, 96, 120, 144, 168. And then you can see there that 168 is the LCM. Either way, hopefully you then realise to get the full marks. So that would give you 2 marks so far out of the 3. But now I need to find the correct time. So 168 minutes is 2 hours. Yeah, because 2 times 60 is 120 minutes. So it's 2 hours and 48 minutes. Okay, so I add that on to 12 o'clock, which gives me a time of 14:48. Or you could have written 2:48 p.m. Yeah, Either one will get you the full marks. Right, question 8. Again, a few ways you could have done this. I'm going to show you one way, but some of you got this correct doing this a different way. I know that the ratio, so I'm going to use this information first. The number of blue to yellow is 3 to 4. I'm told that there are 56 yellow counters. So I do 56 divided by 4, which gives me 14. So I must have multiplied by 14. So I'll do the same to the blue counters, 3 times 14, which means that I have 42 blue counters. So I'll just write this down. So 56 yellow. I've now worked out that I've got 42 blue. I can now find out how many red. So I'm now going to use this bit of information here where it says red counters to blue counters is 5 to 2. So red to blue is 5 to 2. I know I've got 42 blue, so 42 divided by 2 is 21. So I multiplied by 21. I'll do the same on this side. So that means I've got 105 red counters. So 105 red. And so simply it says how many counters do I have in total in the bag. So I've done most of the work. I'm going to do 56 plus 42 plus 105 on my calculator. And that's going to give me 203 counters in total. Okay. This question here, we want to I need to give my answer in standard form. I'm just going to multiply. So literally all you need to do is 2.1 times 8. So 2.1 times 8 gives you 16.8. And then remember when we're multiplying, we add the indices. So I'm going to do 56 plus 54. And so I get times 10 to the power of, what's 56 plus 54? That's 110. Now it's not in standard form. You get 1 mark for just writing that. But now I need to put it into standard form. I'm going to move my decimal point 1 place. So it becomes 1.68. And then that means I need to add on 1 more to here, to the indices to make sure it's still the same number. So it's 1.68 times 10 to the power of 111. Next one, we're adding them now. So it says add A plus B, and it's the same A and B that are here up here. So I'm just going to write it again down here. 2.1 times 10 to the power of 56 plus 8 times 10 to the power of 54. So there are lots of different ways. I know in class sometimes we've turned them back into ordinary numbers and then added them. The trouble is, who wants to write 56 or 54 zeros? No one does. So I'm going to change this I'm going to move the decimal point twice so that it becomes 0.08 times 10 to the, and add on 2 here. So it becomes times 10 to the power of 56. Then I can just add them as normal. So I can do 2.1 plus 0.08, which gives me 2.18. So it's 2.18 times 10 to the power of 56. Now, the only reason I've got to be careful is because it hasn't asked for you to put it in standard form, but you do get 1 mark for writing this as an answer, but it actually asks you that K and N are integers. Remember, integers means whole numbers. Positive or negative, it's got to be a whole number. And so actually, this is where some people perhaps were a bit confused, is we're going to turn this into a whole number. So we're going to have to move the decimal point twice. So K is 218 because this K is the same as this. And then N is my indices. Now, because I moved the decimal point that way, I'm actually going to subtract 2 from my indices and make N 54. Okay, so there we go with that one. Question 10, we're almost there. This one's quite a nice one, so we're going to solve it. The first thing I would do is multiply out the brackets. I would do 3 times 2 minus 4x. 3 times 2 is 6. 3 times minus 4 is minus 12x. So then I make them equal. So I've got 6 take away 12x equals 5 take away 8x. Okay, so all I've done so far is multiply out the brackets from this side. Now I am going to keep my x's on this side, I think, but it doesn't matter if you move it all to the other side. So I'm going to add 8x to both sides to get rid of minus 8x. And I get 6 take away 4x equals 5. I want to get rid of the 6 here, so I'm going to take away the 6. And so I get minus 4x equals minus 1. And then I will divide both sides by minus 4 to get that x must be positive 1/4. Or if you put 0.25, that is also absolutely fine as well. Question 11. Now this one was nice. You got almost 3, as in not 3, the number 3, but free, as in FREE, marks here, because even if all you wrote was you realised that if Simon has X sweets, Ewan has 2 more sweets, so X plus 2. You got 1 mark for writing it. Ewan must have X plus 2. Now, Julia, if that's how you pronounce it, has 3 times as many as Ewan. So she has 3 times X plus 2. And actually, I'm going to multiply out those brackets and get 3x plus 6. But you got 1 mark for just writing one of those, not the x, obviously. But if you wrote x plus 2 or 3x plus 6, you would get 1 mark. Now it says the total number of sweets. So I've got Simon with x, Ewan with x plus 2, and Julia with 3x plus 6. So T is the total. Now I need to simplify. So I've got x plus 3x. So in total I've got 5x. And then I've got 2 plus 6, which is 8. So T equals 5x plus 8. Next one, you can just do it all on your calculator. I would put some brackets in there. I think I would put brackets around this, then divide it by 0.818, then add the square root of 67.4. If you struggle to get it on your calculator, please call me over when we're going through this paper and I'll just see what your calculator prefers. And that's why I tell you to bring your calculators to lessons so that we can do calculator work on there to make sure you're confident in exam. But it says write all the figures. So you should have got 49.87641,697. It depends on how many numbers your calculator holds, but that's mine. And then we have to write it to one significant place. Now, 4 is the first significant number, so I'm going to stop it there. So 4 tens. I need to decide, am I leaving it as 40 or am I going to round up to 50? Now, if I look at the next number, because it's 5 or more, I'm actually going to round up to 50, and that's my number correct to one significant figure. This one was a nice one. We're going to expand the brackets. I suggest that everyone use the grid. Unless you are super, super confident and can do it without, I suggest you use it. So n minus 6 multiplied by n plus 4. N times the n is n squared. N times minus 6 is minus 6n. 4 times n is 4n. And minus 6 times 4 is minus 24. So you got 1 mark for doing that. And sorry, I apologise, this should have read 2 marks here. But I did award the 2 marks if you got it completely right. 1 mark for doing that. And then you should simplify. 4n take away 6n is minus 2n. So it's n squared minus 2n take away 24. And that's your final answer. Right, last question. Well done, guys, for making it this far. Right, we want to get rid of, the first thing I would do is get rid of our denominator here. So, and I'm going to get rid of it by timesing by 4. And I'm going to times all of this by 4. So I have to do it on both sides of the equal sign. And that gave you 1 mark for just working out that 2x take away 3 times 4 is 8x take away 12. And then here, these two cancel each other out. And I get 3x minus 5. Now you can do it as normal. Again, I prefer to keep all the x's on this side. So I'm going to take away 3x from both sides. So then I'm left with 5x minus 12 equals minus 5. Then I'm going to add 12 on both sides to get rid of the minus 12 here. And I have 5x equals positive 7. And I'll divide both sides by 5 to get rid of the times by 5. And I get x equals, and you are allowed to leave it as a top-heavy or improper fraction as 7 over 5. If you wrote it as 1.4, that is also fine. Or if you wrote it as 1 2/5, that is also fine. So any of those, 7/5, 1 2/5, 1.4 will get you the full marks. And that's the end of the paper.